Hello, in this video I'm going to be talking about dynamics. Specifically, I'm going to look at Newton's law, first law of motion, as well as equilibrium. So to start off, and then I'm going to use an example from a AP multiple choice exam to apply these concepts to a real example. So, starting off with Newton's first law of motion, which is also known as the law of inertia, states that an object at rest will remain at rest and an object in motion will remain in motion at constant velocity and in a straight line unless acted upon by a net force. So, just a few defining words. An object is in static equilibrium if it is at rest. Another word essential to Newton's first law of motion is inertia, which describes the tendency of an object to resist a change in velocity. The measure of an object's inertia is its inertial mass, often referred to just as mass. Moreover, a force is a vector quantity describing the push or pull on an object. So now that we've gotten Newton's first law of motion, also one more thing. A net force is just the vector sum of all the forces acting on an object. So now that we've talked about Newton's first law of motion a little bit, we're going to talk about equilibrium, which is pretty similar to Newton's first law of motion. So equilibrium is essentially when the net force of an object is zero. There are two forms of equilibrium, one that I already described, static equilibrium, which is when an object is at rest, and there's also dynamic equilibrium when an object is moving with some velocity. So one common analysis question involves finding the equilibriant force given a free body diagram of an object. The equilibriant is a single force vector that you add to the unbalanced forces on an object in order to bring it into static equilibrium. Once again, static equilibrium is when an object is at rest. So to find the equilibriant, you must first find the net force being applied to the object. And to do this, you apply vector math and add up the two vectors by first lining them up by head to tail. So finally, to find the equilibriant vector, you need to add a single vector to the diagram that will give a net force of 0. So now I'm going to talk about an example from the exam. First, I'm going to read it. It's number 12. It reads, a sphere of mass m hangs from two strings that each make an angle of 30 degrees with the horizontal, as shown in the figure above. What is the tension T in one of the strings? So first I'm going to draw this diagram out for you. We've got our bar here, then we've got T, we've got our sphere that hangs down, and 30 degrees for the angle that forms between the upper bar and the string on each side. So it is asking for what the tension T is in one of the strings. So we know that, first I'm going to draw a free body diagram. So we've got our axes here. We've got T1, or T2, let's put T1 here. Angles of 30 degrees. Angle of 30 degrees with our net force coming down, which is mg. So we know that T1 cosine of 30 degrees is going to be equal to T2 cosine of 30 degrees, because we know from the diagram that T1 and T2 are equal to one another. Then we also know that the sine of each string added together is going to be equal to the mg, because it's going to make a single force vector that adds up to the unbalanced forces to create a net force of 0. So 2t sine of 30 degrees is equal to mg. We simplify this since we know that sine of 30 is equal to 1/2. And we get that t is equal to mg. So once again, the question was asking, what is the tension T in one of the strings? So we've just solved for T, which is mg, and when we look at the answers on the exam, we get that D is equal to mg. So option D is going to be the correct answer for this multiple choice question. Thank you.